In this question, we intend to simulate a simple example having been selected about the strength of materials in the Abaqus software and compare the results obtained from the Abaqus software with those gained from the strength of materials subsequently. In this question, a conical bar to the length of 300 millimeters undergoes a force equal to 20 kilonewton. The purpose of simulating this problem is to calculate the displacement of point B using the Abaqus software as well as the strength of materials formula. As you observe in this picture, the size of the big diameter is 40 millimeters and the small diameter is 25 millimeters in size. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create geometric shape of the bar. Here I'll select the modeling space as 3D, deformable. From here, solid and revolution. Enter approximate size equal to 1000 and continue. As you observe in this picture, the bar is 300 millimeters in length. The size of big diameter is equal to 40 millimeters. I will enter radius equal to 20 millimeters. The size of small diameter is equal to 25 millimeters, so the radius would be equal to 12.5 millimeters. Done. Enter the angle of rotation equal to 360 degrees and OK. In the next step, I will enter property module, click on create material. Here I intend to define the properties of steel. I will click on mechanical menu, then on elasticity and elastic. Young modulus is equal to 200 gigapascal. I will enter Young modulus equal to 200,000 megapascal. Enter Poisson ratio equal to 0.3 and OK. I will click on Create Section, select Solid and Homogeneous, Continue and OK. I will click on Assign Section, select the bar, Done and OK. In the next step, I will enter Assembly module, click on Create Instance and OK. In the next step, I'll enter Step module, click on Create Step, select Static General and Continue. Time period is equal to 1 second. Since this problem is linear by nature, I will select Off option. OK. I will enter Load module, click on Create Boundary Condition, select Initial Step, then Displacement Rotation and Continue. I will select the end of the bar, Done, and close all boundary conditions for it. As you observe in this picture, the left end part of the bar is absolutely fixed. In the next step, I will enter Interaction module. Click on Tools menu, then on Reference Point and select this point. In the next step, I'll click on Create Constraint. Select Coupling and Continue. First, I will select this reference point. Done. Then click on Surface. Select this surface and OK. In this manner, this surface will be coupled to this reference point. In the next step, I'll enter Load module. Click on Create Load, select Step 1, then Concentrated Force, and continue. I will select this reference point. Done. As you observe, a 20 kN force will be applied to the bar. In the next step, I will enter Mesh module. Click on Seed Part, enter Approximate Global Size equal to 3 mm and OK. I will click on Assign Mesh Control. Here, select Medial Axis and OK. Then click on Mesh Part and Yes. I will click on Tools menu, select Set and Create. Name this set Point B. Continue, select the reference point and Done. In the next step, I will enter Step module, click on Create History Output, continue. Here, select Set and then Point B. Then select Displacement directed at Y-axis or the same U2 and OK. I will enter Job module, click on Create Job. Continue, OK, and then click on Submit. The analysis was done successfully, so I'll click on Result. The purpose of simulating this problem is to calculate the displacement of point B using the strength of materials formula and the Abaqus software, and then comparing the results obtained from the strength of materials with those gained from the Abaqus software. Here the problem has been solved using the strength of materials formula. As you observe in this picture, the bar has a conical shape and the diameter of the bar is not constant and it varies from 25 to 40 millimeters. Here, since the diameter of bar varies, the cross-section will change as a result. Here we should define the relation between diameter of the bar and its length. Here, the relation between the diameter of the bar and its length has been fully described. Actually, the diameter of the bar depends on x. Since the diameter of the bar is not constant in this problem, we will use integral in order to calculate the change in length of the bar, which can be observed here. F stands for force and is equal to 20,000 Newton. E is the Young modulus of the steel. A is the cross section of the bar and, as previously mentioned, depends on X. Here, the cross-section relation has been described accordingly. Here you can observe the process of solving this question, and if we simplify these relations, the displacement of point B would be equal to 0.03819 millimeters. Actually, the displacement of point B is the same change in the length of conical bar. Here, x is the length of the bar, that is equal to 300 millimeters. Now here, we intend to calculate the displacement of point B, or the same change in the length of conical bar, using the Abaqus software. I will click on Create XY Data, select ODB History Output and continue. Here I'll select point B and click on Save As and OK. The displacement of point B is equal to 0.038,184, and actually it has been obtained from the Abaqus software. As it can be observed, the results obtained from the Abaqus software are so close to those of strength of materials. In fact, the displacement of point B, having been obtained from the strength of materials formula, is equal to 0.03819 millimeters, and that of the Abaqus software is equal to 0.038184 millimeters. And as you observe, the results obtained in the Abaqus software are extremely similar to those of the strength of materials.